Hello everyone. Today I'll be showing you the plans for my next project, the Magnum Opus. This project has the sole goal of pushing the game to its limit and to see how far storage tech can be taken with absolutely no compromises. And this project is still in the works, and this is just more of an announcement of the project and how it will work and the different features it will have. So to start, this storage system will be encoded. If you don't know what that means, it means that instead of storing items with item filters like a traditional storage, it will be using encoded data. The simplest way to put it is, for example, let's say you have your chests and you give each one a number 1, 2, 3, 4, 5. Now, in reality, you would have a chest for every item. But let's say this is, just for explanation purposes. And then let's say you have an item like redstone dust. You will pass it through a contraption called an encoder. And what the encoder does is it gives you the number for the item. So let's say the number in this case is 3. Well, how you would sort the item without an item filter is, well, if the number for the item is 3, you match it with the chest that has the number 3. So if this is 1, 2, and 3, 4, 5, well, if this is 3, that means it needs to go in here. And you would unlock a hopper and select this chest. And the benefits that is lag efficiency, because most of the hoppers aren't doing anything and they can be locked, and only the specific hopper that the item needs to go into can go in. Another benefit is you can sort things that can't be done in item filters, such as unstackable items or entire shulker boxes, or you could even mix different items by giving them the same number. Now, you may notice there's no such thing as numbers in the game. And how would it be done? Well, you have two options. You can do binary, which you may be familiar, or you can do hexadecimal. Hexadecimal is instead of how we normally count, which is decimal, which has 10 digits, 0 through 9. Instead, it has 0 through 16, and it's surprisingly more common than you think. For example, if you're doing some computer art, you may notice that the colors have letters in them. For example, 019FA, and that's because those are hexadecimal digits, which after 9 you don't have any more numbers, so you go A, B, C, D, E, and then F. Things like error codes are often done in hexadecimal, and the reason is because it's a way for humans to easily read numbers that work well with computers. As computers work very well with powers of 2. That's why items stack to 64, and also dust has 16 states, 0 through 15, which is the exact same as hexadecimal. And binary is also very easy. It's just simply having multiple redstone lines or signals. Each one of these would be a binary bit that's either on and off, and that's how you send the numbers by turning them into their binary form. And hexadecimal is also just signal strengths that you can use comparators to transfer the signal and do some calculations on them. Now that you know how the actual system will sort the items, what can we do with that power? Well, the system will have 3 main areas. Say this is the center. There will be 2 wings of the main storage. So these will be specially designed accessible temporary storage, and I will explain a bit what that means. And then we'll have our bulk on the side here, and these are for items that you have a lot of, usually things that you have farm outputs, and they will be stored in shulker boxes in very large quantities. And then this side will be the main hall, which will look like a traditional item hall with the 8 chests surrounding the hallway. So what is an accessible temporary storage? Well, let's say you have a shulker box of items, and you put in, let's say, a lot of gravel. Well, you only want to put in full shulker boxes into the storage system if you're going to store them. You don't want a bunch of half-filled shulker boxes. So what do? If this is not full, do you unload it and put it in as items, which you can do, but that will eventually fill up and it's very space inefficient. What you do is you create a temporary storage. The temporary storage holds one shulker box of every item, and it can be called whenever another box of the same item type comes in. So let's say this is sitting in the temp storage, and there's many ways to do this, but it's usually just a bunch of chests that you can call items from. And then you get another box of gravel that you want to sort. And it doesn't matter how many are in here. What you do is you grab both boxes and you put them through a contraption called a merger. So what the merger does is if there's two boxes here, it will take the items from one box and it will grab them and it will put them into the other one and it will merge the two boxes together. And there are two outcomes. The first one is like this, where you end up with another box that is not full and an empty box. The empty box gets sent back into the empty box storage, and this box, since it's not full, it goes back into the temporary storage and waits for another box. If you get another box of items, it will start to try and fill here. Now this box is full. Once that is full, it stops. And now this is now a full box of gravel. It can be sorted and stored. The remaining box goes back into the temporary storage and waits for the next box of that item type. And this basically lets you store only full boxes without having a bunch of half-filled boxes. But you may notice one flaw. The temporary storage stores items that are less than a box. Well, let's say you don't have a full box of items, then you have items in the temporary storage that are separate from the rest of the world. That's why an accessible temporary storage is special, as instead of storing the temporary boxes in a chest, it displays them next to the chest of items so that the player can still access those remaining items. And I do have one designed already. It's complete, and that's what the next video will be about when it comes out. For now, that's basically what the system does. And another feature is most of the time, binary signals are just stored in multiple lines of either rails or wires. However, in this one, we will be using packets. This is a naming I came up with. Which you may notice, this is actually a binary number. Each one of these water bottles corresponds with a 1, and any other unstackable item is a 0. So this is 10010110001. And how do you get that information out of the box? By using brewing stands. So if you have a brewing stand and you try to put in anything that is not potion, it will not go in. But if you grab any potion, so for example a water bottle, it would go in. You'll notice it goes in. So if we put a hopper underneath, we can grab that item. And by creating this circuit, we can create a serial output, so that's just ones and zeros in order. We can get the data and store it into packets and get the data out whenever needed. This has many benefits, as you can store data very compact, as you can just put a bunch of these into a double chest for item queues, or you can cache items within the storage hole. And there's many benefits that I will explain once they are included in each component. But for now, that is how the data is stored and sent around in the storage system, is within these shulker boxes. Another benefit is, let's say you have a farm. Well, you can have the farm create these packets so that the storage system already knows what the item's number is, and it can quickly sort items, and you can send them from around the world and directly store those items into your main storage system. Another thing is, this bulk will store items on its own, but for items that you have a very large quantity of, other than this one here, there will be a self-organizing bulk storage. And how this works is, it's a very space-efficient bulk storage design, as it only stores items that are past the default bulk, and it's basically extra storage for items that need it. So it will have a set number of chests representing each one of these columns, and once you start filling up a row with each, let's say whatever this box is, it will allocate another row. So let's say you get more of whatever these red boxes are, and the colors don't matter, it's just to represent a different item. So it will start filling them up, and once this column's filled, it will now go on to the next column. And let's say you want to take out another item, let's say this green box. It will search for the lowest item, one that's filled least, and it'll take the item out. And now that's free. If you get another item that's now too full for the other storage, for example this yellow box, it will then find the next open storage hall and put it in here. And you can see that it's very space efficient since nothing takes up more storage than it truly needs. And also, if you have a bunch of different items, but not all of them need a bulk, but you don't know which items you'll have to store the most of, this can handle it all. So this is just the for items that you have a lot of, mostly just farm outputs or anything like that. And that's pretty much it for now. There will be a lot more features that will go into detail that make this special, and it will be a very complicated and very large system. But when it is complete, it will be undoubtedly the most advanced storage system in the game, including Java, and that is the main goal of this. I will not be probably doing this solo. I'll be asking for the community's help, and any help will be taken and greatly appreciated. And thank you for watching. See you in the next one.